So this is the second day of section 7.3, which is multiplying and dividing and then simplifying rational expressions. So today we're going to do division. And the very first step is the same very first step that it was with multiplication, or the same very first step it was with just simplifying, which is what? Tessa, what is it? We're going to factor anything we can possibly factor. Our first step, let's factor this bad boy. We've got 7x, which can be 7 times x, but you don't necessarily need to write 7 times x. 2x minus 10 has a greatest common factor of 2. X squared minus 6x has a greatest common factor of x. And then x squared minus 11x plus 30 is a trinomial that I'm going to guess and check. Looks like it's going to be minus 5 and minus 6. So very first step, we are factoring. And then what I have to do is I have to write out those domain restrictions. So x minus 5, that would be, remember last time we said you set x minus 5 equals 0 and then we solve it. I don't normally write all of the steps. I just normally write x does not equal 5 because I can do that in my head. This one here, x does not equal 5 and x does not equal 6. So the fact that I have x does not equal 5 twice doesn't matter. I don't have to write it twice. It doesn't matter if you write it twice or not. Okay. Now, does anybody notice something right away we can do to simplify this before I even divide it? Do you guys see something we could simplify before even dividing? Nina, what do you see? Yeah, let's just cross out those x minus 6's. Let's get those out of the way, and that way we just have something simpler to deal with. So now I've got 7x times 2 times x minus 5 divided by x over x minus 5. What is the rule for dividing fractions? What is the rule for dividing fractions, Nita? Yeah, we don't divide fractions. We multiply by the reciprocal. So at this point, I'm going to change my division into multiplication. So instead of dividing by a number, I'm going to multiply by its reciprocal. So I'm going to have 7x over 2 times x minus 5 multiply by, now I reciprocate the second one. We always reciprocate the second one. If you reciprocate the other one, you're going to get it wrong. Now here, so that's different because we didn't divide before. So now we're multiplying. We already know how to multiply. When we multiply, the first thing we need to do is check for domain restrictions. So we're going to do that again. So that's happening a second time. So this one's going to be x does not equal 5. And my second one is now x cannot equal 0. Okay, so we have these two domain restrictions. Back this way, we had these two domain restrictions. So really, we've had 3 domain restrictions so far total. 3 different ones, I should say. Okay, now once you get to multiplication, we already know how to multiply. That's what our lesson was last time. So how do we multiply? How do we multiply fractions? Who's talking? Joel? No, we're not going to combine like terms. How do we multiply 2 fractions in math? Straight across. Straight across. Multiply straight across, goes straight across, straight across. And so my next step is going to look like 7x times x minus 5 over 2x times x minus 5. Okay, multiply straight across. Now we can simplify. Anything cross out? Anything cancel? Only if they're factors. Jacob, anything cancel? X minus 5 and x minus 5. Is that it, Jacob?
The x on the 7x and the 2x.
Right. So this x is 7 times x, and this x is 2 times x. So the x itself, those are factors. So if they are factored, we can cancel them out. So we get 7 over 2. We're going to check domain restrictions. We're going to check the domain restriction on the simplified expression. When I look here, 7 over 2, there is no variable in the denominator, so there is no domain restriction. So when we write our answer for this, we're going to write 7 over 2, but we have to put in any domain restriction we had that is not there anymore. So a domain restriction that we had that isn't there anymore is 5, 6, and 0. So we've got 3 of them here. So how this is different is we have to check our domain restrictions 3 times. We checked it right at the beginning, as soon as we factored it. We checked it after we flipped the second fraction. And then we check it at the end. There's 3 places rather than just 2. But everything, if you understood multiplication, then this should be super easy. We just got to like flip one to do it. So we do another example. Dividing rational expression. This time it's by a polynomial instead of a fraction. So first thing we're going to do, any guesses? Factor. We're going to factor first. That's going to be like a common pattern you're going to see in this entire chapter. So, okay, so factor first. Oh, we've got a more challenging one to factor here. I'll give you guys a moment to see if you can factor the top of that one. Ashlyn, did you get it factored?
Yeah.
What'd you get?
3x plus 5.
2x minus 3? Is that what you said? Okay, good. Very good. Another thing that just might be helpful if you're stuck factoring, me factoring the rest of it, well, I mean, there wasn't that much more to factor, but me factoring the other part might give you a hint on what to try factoring the first one. Because of this 3x minus 5, I was like, I wonder if that's going to be one of the, I wonder. Because the book likes to give you good ones that work out. What's up? What happens to the 6? Okay, so instead of factoring, what happens if I multiply this back together? If I multiply, you know? Okay. All right, so we have factored it. What's our next step? What's our next step? Ella, what do we do after we factor? The restrictions? Yep, domain restrictions. So the only thing in the denominators is an x or an x squared, which is going to be x does not equal 0. It's the only thing that's there. So our next step is instead of dividing, we change it to multiplication. So I keep 3x plus 5 times 2x minus 3 over 4x squared. I change it to multiplication. And then I flip the second one, 1 over x times 3x plus 1. Plus 5. So I flip the second one. So now this becomes multiplication, and we're going to start multiplication from scratch. We're going to start over multiplication. Ryan, do you know what I need to do next?
You gotta find the domain restriction.
Perfect. We got to find the domain restrictions again. This time, x does not equal 0 is still there. But over here, we've got another x does not equal 0. It does not matter if you write it twice or just write it once. And then we've got 3x plus 5 does not equal 0. So I'm going to solve that. 3x does not equal 5. So x does not, oops, I don't know how to do it. Negative 5 and does not equal negative 5/3. There we go. So I got x does not equal 0 and x does not equal negative 5/3. When we multiply, how do we multiply fractions, Holland? How do I multiply fractions?
Straight across.
Straight across. So I'm going to go straight across. And when I multiply 4x squared times another x, that's going to up the exponent, 4x cubed, times 3x plus 5 in the denominator. So multiplied straight across. Sierra, when you get a second, what should we do next?
You can check the domain restrictions.
Well, I don't need to do that because they're going to be exactly the same as the ones prior.
Cancel out.
Cancel. Yep. What should I cancel?
3x plus 5.
3x plus 5. Is that it?
Can you cancel out x's?
Can I cancel out the x's, you guys? Can I do these x's? Mar, you're saying no. Why? Can you pull your mouse down just a little bit? You like put it up when you started talking, and I couldn't hear you.
Yeah, like one parentheses, the other's fine.
Okay, so one's in the parentheses, the other's not, because being in the parentheses, what does that mean when he says one's in the parentheses? What does that mean? It's like part of a factor. And we can only cancel factors. So if there's an x that gets factored out from 2x minus 3, I could cancel it, but that's not factored out. So we cannot cancel those. Oops. So we just now have 2x minus 3. That's one factor. On the bottom, 4x cubed. That's a 4, an x, and x, and an x. So I've simplified. Aya, what should I do now? Domain restrictions for the third time. So much work. That has just x's on the bottom, like by themselves. So just x does not equal 0. What we need to do is look to see if we lost any domain restrictions along the way. Was there a domain restriction earlier that I didn't write in my final simplified answer? Sophie, what is it? I didn't hear you, hon. So this is the answer. And the domain restriction for the answer is only 0. Now, all the ones that I circled prior to that, not all of them were 0. So I need to put that one in. X does not equal negative 5/3 is the one that I have to add in. So now we have all the domain restrictions in our solution or in our simplified answer. You know, the first time we ever did the domain restrictions was last time, so for you to be rusty on it is okay. If you still have questions on it, it's okay. You got to ask though. All right, let's try the next one. Find the quotient. Quotient means divide, or the answer of division. So the first thing that we're going to do, Brooke, what's the first thing we're going to do? Factor. So I'm going to factor 5x minus 20. I'm going to factor out a 5, x minus 4, divided by, on top, factor out an x minus 2. And then on the bottom, I've got a trinomial. So I'm going to factor it to be x minus 2 and x minus 4. Ella, after I factor, what should I do next? Domain restrictions. Excellent. Oops. So let's see. X minus 4, that can't equal 0. What the heck am I doing here? That can't equal 0. So then we have x cannot equal 4. X cannot equal 2. And then this x cannot equal 4 again is the same thing. All right, we did the first step. Next. Tessa, what should I do next? Oh, okay. Yeah, we could do that now. Sure. Oops. Gosh. I keep hitting the wrong buttons. Okay, I think it's not me. I think it's Cammie. Okay, I think I got to refresh my Cammie because it's not working. There we go. All right, cancel out the x minus 2s. That's going to give me 4x over 5 times x minus 4 divided by x over x minus 4. Nina, what do you think I should do now? Change it to multiplication. So it's division right now. We're going to change it to multiplication by multiplying by the reciprocal. So we're going to do 4x over 5 times x minus 4 multiplied by x minus 4 over x. Ariana, what do you think we should do now? Multiply straight across, okay. No?
Yeah.
Okay. So I'm going to have 4x times x minus 4 over 5x times x minus 4. Ketsia, what do you think we should do? I don't want to cancel yet. There's something else that I need. When we did multiplication the first time, domain restrictions. So remember, guys, we check it when it's division, and then we need to check it again. And it could have been before multiplying. It could have been before multiplying. We would need to check it again before canceling with the multiplication. And I now have 0 and 4 when originally I had 4 and 2. So things are going to change. That's why we need to check it before and then after the multiplication. Let me rephrase that. We're going to check it when it's division and check it when it's multiplication. So now that we've checked it, now we can cancel. Looks like the x minus 4s cancel, and then the x by itself cancels. So we get 4/5. Jacob, what should I do now?
Check domain restrictions.
Okay, well, there aren't any domain restrictions because it's just a 5. So if there's no domain restrictions, but there were, yes, Sophie? Go ahead.
I was gonna ask him where the other ones were, but you're not done.
Well, if there were domain restrictions, but now there's no domain restrictions, why did they go away? Because we did what? Where'd they go? Do we not know the answer? Or are we just being quiet? Ryan, do you know where they went? There were domain restrictions. Now there aren't anymore. Jackson, do you know where they went? Aya, do you know where they went? Ariana, do you know where they went? Okay, so this is important. If you guys don't know where they went, do you know where they went? I feel like you all are just like being bashful and not saying what you think because you're afraid you're going to be wrong. They canceled out. Yeah, they got canceled. So, well, yeah, every single one of them got canceled. So at the beginning, 4, and then the 2s got canceled. So that 2 disappeared. Down here, we've got 0 and 4, and they both canceled out. That's where they all went. They got canceled out. But because they're not there, we have to put the comma. We have to say x cannot equal 0, x cannot equal 2, and x cannot equal 4. We have to go put every single one that was in that answer. So work on the next one. I'm going to pause this video. Work on the next one. So our first step is to factor, and I was helping somebody factor on the board over there, so I already got it factored. 2x plus 5 times x minus 1. On the board, or on the bottom, I've got 6 times x. Divided by, I'm going to factor 2. Nope, I'm not going to factor 2. I'm going to factor an x multiplied by 2x plus 5 over 1. And so factoring this side over here might have given you a hint on what to try on this side. Just, it won't for sure always work that way. But since this is the first time we're learning this stuff, it's going to be a little bit easier. Then what do we do after we factor? Evo, do you know what I do next? Not yet. Can't change the multiplication yet. Domain restrictions, yes. So we're going to do x does not equal 0. Now we'll change it to multiplication. So change it to multiplication. The first one stays the same. Multiply. Second one is the one that flips. Yes, Tessa.
Before I changed it to multiplication, I canceled out the x in front of the 2x plus 5 and the x, then it says 6x. Is that still okay?
So you can't cancel when it's division. You can only cancel when there are factors on top of each other. So you're thinking of something that you learned, I don't know what year, maybe 8th grade, maybe in Algebra 1, called cross-canceling, where if it's multiplication, like in the place where I am right now, I could, but I don't like to, I could right now go ahead and cancel those, because when I do multiply, they're all going to become one big fraction. So that doesn't work with division. So that's why when I'm introducing it here, I don't use those shortcuts as much, because then we get confused. Yeah. So that only works for multiplication. That does not work for division. Good question. So here, I'm pretending I didn't cancel those. Okay. So from here, we're going to actually, no, we can't multiply yet. Why? What do I need to do before I multiply? What do I need to do before I multiply? Yes, Ashlyn. Domain restrictions, my second time. So this one's still x does not equal 0. I meant to put that in blue. You guys see how I'm trying to like color code it the whole time. This does not equal 0. And then this 2x plus 5 does not equal 0. I have to solve that. 2x does not equal negative 5. X does not equal negative 5 halves. So then we'll multiply straight across. 2x plus 5 over x minus 1 divided by 6x squared times 2x plus 5. So multiply it straight across. And now is where I'm going to cancel stuff. Those 2x plus 5s will cancel. And so I get x minus 1 over 6x squared, just over 6x squared. And I got to check my domain restriction one more time. And I only have 0 for the domain restriction. So because originally I had 0 and negative 5 halves, and I lost the negative 5 halves, I have to put that back in. X does not equal negative 5 over 2. So that quiz that we took today, I gave you a multiple choice one so that the domain restrictions were there, because that's the part where people tend to forget. But eventually you'll be writing them. Eventually you'll be typing them in. So we want to make sure that we know how we're getting those domain restrictions when we get to the quiz in the future, where I don't give you just all multiple choice. All right, the last part of today is simplifying complex rational expressions. When it's complex rational expressions, we've got fractions inside of fractions. And that is not appropriate to leave fractions inside of fractions when you're simplifying. When we simplify, we should only have a fraction, not fractions inside of fractions. So what we're going to do, and there's different ways to do this, and if you fly through this stuff and you want to learn a shortcut, I will teach you a shortcut. I will not teach the whole class a shortcut. So if you fly through this stuff and you're like, give me the shortcut, I need it, then we talk. What we want to do, this is not the shortcut. This is the regular cut. The numerator and denominator must be each a single fraction. So right now in question A, do I have a single fraction over a single fraction right now? No, I've got two fractions over two fractions. So we first need to make it a single fraction. If it's not, we're going to find a common denominator, add and subtract the fractions to make a single fraction. So in question A, we do not have a single fraction on top. So I need a common denominator for 3 and 4. What's the common denominator for 3 and 4? You should already know from previous courses. 12. So we're going to multiply 2/3 times 4 over 4 minus 1/4 times 4 over 4. So that will give me 8/12 minus 4/12, which will give me, oh, I ran out of space, which will give me 4/12. Eventually I will. I kind of ran out of space. On the bottom, we're going to do the same thing, but it won't necessarily be the same common denominator. So what is the lowest common denominator for 6 and 2? Ariana? Did I make a mistake? Yeah, I should. Thank you for catching my mistakes. When I get up here and I start talking, sometimes I miss stuff. Appreciate it. So 5/12. Okay. All right. In the denominator, 5 over 6 and 1/2. What would be the common denominator of 6 and 2? 12. No, 12 would be a common denominator, but it is not the lowest. 6 is the lowest common denominator. So we have 5 over 6. That one already has the denominator. Plus, I'm going to take 1/2. And you guys could probably do this without writing the step that I'm writing right now, but I'm making sure that I'm writing everything out for those of us that aren't able to do it in our head. So now I have 5 over 6 plus 3 over 6, which gives me 8 over 6. Okay, so now once we get to one fraction over one fraction, we can look at the second step that says rewrite the complex fraction as division. So I'm going to rewrite this as 5/12 divided by 8/6. So I took 5/12 over 8/6 and changed it to 5/12 divided by 8/6. I haven't done anything but just rewrite it a different way. And then step 3, now we're just going to follow the steps we learned for dividing. So for domain restrictions for this question, there's no variables. So I don't even need to worry about domain restrictions because there's no variables. These are just numbers. So right now I have it as division. What do I do next? Flip it and multiply. We're going to multiply by the reciprocal. That is our next step. So I will have 5/12 multiplied by 6/8. We can go straight across. If you guys did reduce it, like 6/8, if you reduce that, that's totally fine. If not, which I didn't, then I'll just reduce it now. After I multiply, I'll reduce it. So I get 30/96. Is that 96? If I had reduced it, I would have had smaller numbers. Maybe I should reduce it. We can reduce it right here. 3/4. There we go. Now multiply straight across, I get 15/48. Does 15/48 have any factors in common? 15 divided by what? And 48 divided by the same number? Yeah, Nina? What? Yeah, it's divisible by 3. So this would be like 5 times 3, and this would be 16 times 3. So if we can factor out that 3, then we can cancel it. If we can factor it out, we can cancel it. And I get 5/16. So the original question, the original expression is equal to 5/16. And I think you'd agree with me, 5/16 is much simpler than the original one. Yeah? Okay, question B. Now we have variables. We're going to do the same thing. Question B, we only have one fraction over one fraction to begin with. We only have one fraction over one fraction, so we don't have to do that first step. So now we're going to go to step 2 that says just rewrite this as division. 3/x divided by 9/x squared. So that's my first step, is rewrite this as division. Now we're going to do all the steps for division. What is like the first thing that we learned how to do, not learned how, but learned to do today when we start out division? Nope, that wasn't the first thing we did. We will do that, but not first. What's the first thing we need to do? Factor. Okay, so this one, when I factor it, I'm not going to factor it because it's like 3 times 3 and x times x. If you want to rewrite it as 3 times 3 and x times x, you totally can. I'm not going to because I just like think about that in my head. What do I do next after I factor? Brooke, do you know what I do next after I factor? Domain restrictions. So we look at our domain in our denominator. X cannot equal 0. And x squared, that's also x cannot equal 0. So this is our only domain restriction at the beginning. So we factor it, find domain restrictions. Next, change it into multiplication. 3/x multiplied by x squared over 9. Sierra, do you know what I do now? I will, but I like to do something before I do that. But do you know what the other thing I have to do besides multiply straight across? I do have to do that, but do you know what else I need to do? We have to do this when we divide. We also have to do it when we multiply. have to do it multiple times. Domain restrictions. Okay, we do it when it's division, then we do it again when it is multiplication. It's still the same one. We're fine. It's still the same one. After we multiply straight across, then what can we do? What can we do? Jackson. Say what to the exponent? Oh, subtract. We're going to simplify it, reduce it, cancel, stuff like that. Yes. So remember, this is 3 times x times x. I did not have to write this out. I'm just doing it because this is what is in my head. This is what's in my head. So you guys can see what's in my head. So I have a 3 that will cancel, and I have an x that will cancel. So now I have left x over 3. Amar, what do I got to do? Domain restrictions. But when there's a 3 down there, there is no domain restriction. Because there was a domain restriction and now there isn't, I just got to put it in as part of my answer. All right, just 2 more and we're done with the notes. Oh my gosh, we're not going to have time for 2 more. You know what I'm going to do? I'm going to work through these. The bell's going to ring. I'm just going to keep working through them. If you guys need a pass, you can still come get one from me. But I'm going to work through these just so they're on the video. Okay?
Good Monday, good morning, Lakota West. We hope that you had a great weekend as we settle back in here. That song was for our seniors, coming from our teachers. Don't get that senioritis on the students too now. We still got 6 weeks to go. We love you, but don't make us lose our minds up in here. Seniors. All right. Hey, welcome back, everybody. We hope you had a great weekend. It was a busy weekend here at Lakota West, of course. What an outstanding performance. Site and purchase a streaming ticket at LakotaWestTheater.net. You can find the link on the homepage. Streaming tickets are $25. But keep in mind, you are supporting the theater. Revenue's been down this year due to COVID. So you're supporting the theater and supporting your classmates and also just, I mean, it's unbelievable. I am telling you, it is breathtaking to hear the music and singing and acting and dancing. The choir really is. And I brought my mom yesterday. All right, so you can find that link. You can select one of 8 viewings from April 23rd through the 27th. Don't miss the amazing show from the comfort of your own home. All right, seniors, the 2021 Senior Academic Night will be held here at Lakota West on the 27th of April. It will take place at the gym at 6:30. Please check in with Mrs. Bischoff if you arrive that evening, so we know how to properly announce your name. Seniors who have maintained a weighted cumulative GPA of 3.5 or above your entire 4 years will be recognized. If you have any questions about whether or not you will be receiving an award, there is a list hanging outside the annex office. Also, seniors, we need that senior survey. As of today, only 25% of you have completed it. It is mandatory. We really need to know every person that's going to participate in graduation due to some of the restrictions we're working around with attendance and capacity, as well as we need accurate information so that we can properly highlight all the great things that our seniors are doing. So please do it today. Don't delay. Take that senior survey on Naviance. All right, join us for GSTA meeting Tuesday, April 13th at school in room 104. No club card required. Hey, who likes Kona High? We all do. Well, guess what? Head on out after school tomorrow and grab some Kona Ice. It'll be outside the main entrance, and you'll be supporting our Lakota West bands if you do. Thank you. Hope to see you there. And enjoy a little Kona Ice for sale tomorrow after school. Air testing starts Wednesday, April 14th. We have geometry and algebra 1. The next day will be U.S. history and government, and then biology concludes on Friday the 16th. All of those tests will start at 8:05 a.m. And if you are not currently enrolled in the course or courses being tested on a particular day, you do not need to arrive to school until classes start at 11:25. Classroom assignments for face.
So in this question, when we do our domain restrictions, because there's both an A and a B down here, we have to say that A does not equal 0 and B does not equal 0. Oops. And the same thing over here, but they're the exact same answer, so I don't need to write them twice. And then we change it to multiplication. Let me just zoom in a little bit here. Change it into multiplication. I've got A plus B times A minus B over 4A squared B multiplied by 16AB squared over X. Oh, it's not an X, that's an A. Sorry about that. A plus B. And then we do our domain restriction again. And we have that A does not equal 0, B does not equal 0 for these two here. But over here, we have to put A plus B does not equal 0. And it doesn't matter which variable you solve for. So I'm just going to solve for the first variable. A cannot equal negative B. So this is a new domain restriction. And then I can cancel, well, I'm sorry, multiply straight across, then cancel. A plus B, A minus B. I probably should have put this in front, but I wasn't thinking. 16B squared, 4A squared B, A plus B. We're going to cancel the A plus B's. I'm also going to cancel a 4. I'm going to cancel one of the A's and one of the B's. So left over, I have A minus B. Nope, left over, I have 4B, A minus B. And then on the bottom, I have A. So I check my domain restriction one more time, and I have that A cannot equal 0. So the two that I have to add on are B cannot equal 0, and that A cannot equal negative B.